Hello everyone, we are Shadow Learning. Our project is Hidden Fashion. Our task is based on Deep Fashion 2. This dataset contains 491,000 images of 13 popular categories and has richer annotations compared with other existing datasets. Unlike previous work that is working on the image level, this dataset contains multiple items present in a single image. Our goal is to help improve performance of fashion image analysis in real-world applications. We collect data by controlling their variations in terms of four properties as shown in the figure. And we have three main tasks: landmark estimation, class prediction, and close retrieval. We made several attempts for this data challenge. We first tried VGG16 and 19 in the midterm, and then transferred to MobileNet v2. Finally, we re-implemented MaskRCN and made several improvements. We proposed our model, MagRCN. Here's the overall architecture. The model is based on MaskRCN with additional keypoint and flip channels. The first stage is Feature Network, which is composed of ResNet 101 and Feature Pyramid Network. Each time, we feed a pair of images into the ResNet, and then FPN used a top-down architecture with lateral connections. ROI Align extracts features from different levels of the pyramid map. In the second stage, Perceptual Network contains three streams of network as shown in the figure. It jointly learns three tasks which demonstrate extraordinary efficiency. The object function is to minimize four loss functions, which are formulated as above. We used cross-entropy for class, keypoint, and mask, and a smooth loss function for bounding box regression. Unlike the baseline model that employs ResNet 50, here we use ResNet 101 backbone to extract features. Originally, we tried the lighter weight MobileNet, but it turns out that it would suffer from misclassification, especially for those clothes that have high color contrast. Therefore, we use ResNet 101 instead. Even though more parameters are required, it is still much lighter than VGG. To further control the model scale, we resize the image to the longest edge of no more than 1024 pixels. Additionally, we magnify the key points and perform standard data augmentation with random horizontal flipping. This helps draw a clearer boundary of the landmark. Finally, we jointly learn the framework of these three tasks using different streams and aggregate them at the end. This significantly improved the accuracy. It turns out that the MobileNet v2 has a worse loss. VGG16 and 19 performs a little bit better, but still have a loss near 1. MaskRCN and MagRCN, on the other hand, perform well on this task. One of the interesting is that MagRCN outperforms MaskRCN in the mask task. We guess it is because we add the key point in our model. We also find that the classification error is higher than the baseline, so we conducted an error analysis. We randomly selected 100 images and classified each error into different categories. We find that the clothes like jumpsuits or images with complex pose are easily misclassified. This is just a process of how our model retrieves the clothes. These are the same clothes, but from either buyer or seller side. Above is from the shop, and below is a real customer try-on. Here, Top-K retrieval accuracy is adapted to measure the performance of retrieval task. It turns out that the MagRCN improves the model accuracy by 3.66%. To conclude, we propose MagRCN to classify the clothes and realize close retrieval. For further improvement, we will consider applying graph reasoning network to address the misclassification problem, and hopefully realize one-click dress-up change. That's the end.